In this lesson, we are going to be answering questions like, which function has a derivative of cosine of x? Which function has a derivative of 2 times x? These are called antiderivatives. Antiderivatives are the inverse operation of taking the derivative. So they undo taking a derivative. The notation to find the antiderivative is a kind of long curly S, and we'll see why that notation comes in later in a future lesson. And then we have a dx at the end, and that equals x squared plus c. So the antiderivative of 2x is equal to x squared plus c, and this is also called an indefinite integral. The c is a constant, and the purpose of c when I think about graphing is this is a vertical shift because it happens after I've evaluated the function. Well, a vertical shift the slope remains the same whether my graph went through 0, 0 or my graph went through 0, 2, something like that. The slopes are the same in corresponding parts, and so it really doesn't matter what this plus c is, but we always put it in unless we are given more information about our original graph. The plus c isn't going to affect us on the derivative because the derivative of a constant is always equal to 0. So to check our answer, we're just going to take the derivative of x squared plus c, and we get the derivative of x squared is 2x. The derivative of our constant is 0, so I get 2x plus 0, and it equals 2x. So we did find which function has a derivative of 2x. So here we're going to list a bunch of the basic antiderivatives, and these should all look very familiar to you. First one is our power rule, and the power rule only works when k is not equal to -1. The antiderivative of 1 over x is the natural log of the absolute value of x, and that's because the domain, we have to think about domains. The domain of 1 over x is all numbers except for 0, but natural log is restricted to having domains of only positive numbers, and so to make sure that our input is positive, that's why we have an absolute value there. The antiderivative of e to the x is e to the x plus c. The antiderivative of cosine of x is sine of x plus c. The antiderivative of sine of x is negative cosine of x plus c. And the antiderivative of m is mx plus c. And this is because we're asking which function has a constant slope of m. Well, that would be a line. Y equals mx plus c in this case. Continuing on with our rules, if we're finding the antiderivative of 2 functions added together, it's no surprise that we could just find the antiderivatives of each term individually and then add those together. The antiderivative of a constant times a function is the same thing as factoring out that constant first and then take the antiderivative of f at x. And the antiderivative of 0 is just equal to the constant c, because the derivative of a constant is equal to 0. In our textbook, you can find a table with all of these basic properties listed out on page 201. So we've already looked at this page. So the last thing that we're going to talk about is initial value problems, and this is where we're going to solve for that plus c. Because sometimes we have a particular point that our function needs to pass through. So which function has a derivative of 2x, but also passes through the point 1, 4? Well, the antiderivative of 2 times x is x squared plus c. And I'm going to call that capital F at x. And we are told that f at 1 equals 4, but that's the same thing as 1 squared plus c. Subtracting 1 for both sides of the equal sign, we get 3. And so capital F at x equals x squared plus 3. That's the function whose derivative is equal to 2x, and it passes through the point 1, 4. Another place where we see these initial value problems is when we talk about the movement of an object. So if p at t is its position, then the derivative of position is velocity, and the derivative of velocity is the second derivative, and that is acceleration. Going in the other direction, if a of t is the acceleration, its antiderivative is velocity. And the antiderivative of velocity would equal position. So let's look at an example. The acceleration of gravity is negative 32 feet per second squared. And so let's say that we throw an object up into the air with an initial velocity of 20 feet per second. Its velocity function is the antiderivative of acceleration. The antiderivative of negative 32 is negative 32t plus c. And here we're using a t because our input values is time. Since v at 0, my initial velocity is equal to 20, we can solve for c, and c equals 20. And so our velocity function is negative 32t plus 20. And that is a brief introduction into antiderivatives, which is section 5.1 of our textbook. I encourage you to review the chapter as well as re-watching this video if needed, pausing where it was going too fast for you, and making sure you bring your questions with you to class on Monday.